Hello students, today we will discuss another application of the dimensional analysis. We have already discussed two applications. First one, we have discussed how to check the correctness of a formula, whether a formula is dimensionally correct or not, that we have checked. And second one, to derive the relationship among various physical quantities, that we have done. Now we discuss the third one, that is to convert a physical quantity from one system of unit into another. Suppose the value of a physical quantity given in one system of unit and we want to convert into another system of unit using the dimensional analysis. Let us see how to convert, and this is based on the fact that whatever may be the system of unit, the magnitude of the physical quantity will remain same. For example, 1 meter. In SI system, the one length is 1 meter given. What is the value in CGS system? The CGS system it will be 100 centimeter. 1 meter and 100 centimeter both are same. They are not different. Magnitude remains same. 1 meter, 100 centimeter both are same. As the size of unit is different, the numerical value is different. 1 meter, the size of the meter is more. That's why the magnitude is 1. The numerical value is 1. 100 centimeter, the centimeter the small size, so the number is 100. So 1 centimeter same as 100 centimeter. 1 meter same as 100 centimeter. Now suppose in general, suppose Q is a physical quantity. We will take Q a physical quantity, and suppose the size of the unit in two systems. In one system the size is suppose U1, another system the size of the unit is U2. So the numerical values will be different. So I can write N1 U1, that is equal to N2 U2. N1 is the numerical value in system 1. U1 is the unit in system 1. So physical quantity Q is equal to numerical value times the unit. Suppose a mass is expressed as 5 kg. 5 is the numerical value, kg is the unit. Suppose one system, the numerical value is N1, unit is U1. So we can write N1 U1. In another system, the numerical value is N2 and unit is U2. So the quantity will be N2 U2. What example I told you? Suppose 5 kg, 5000 gram. If U1 is kg, so N1 will be 5. If U2 is gram, so it will be N2 will be 5000 gram. So 5 kg and 5000 gram both have the same value. Magnitude will not change if you are changing the system of unit. That part or that fact is taken into account here. Suppose in general I will take two systems of units. Suppose system 1, I will write like that, system 1 and system 2. In system 1, the size of the mass is M1 and here size of the mass is M2. In system 1, length is L1, here length is L2. System 1, time is T1, in system 2, time is T2. Here the numerical value is N1 and here suppose numerical value is N2. So now the numerical value may be different, but the dimensional formula will remain same. We are finding the dimensional formula. Dimensional formula for force, for example. Whether it is SI system or CGS system or PS system or any other system, the dimensional formula will not change. As the size of the mass, length, time or fundamental units are different, so the numerical value will be different. Otherwise, the magnitude will remain same in both the systems and dimensional formula will remain same. Suppose there is a physical quantity whose dimensional formula or dimensions are A, B, C. Dimension of mass is M, dimension of L is B, dimension of T is C. Now I can write this way: N1 into M1 to the power A, L1 to the power B, T1 to the power C. That is equal to N2 M2 to the power A, L2 to the power B, T2 to the power C. Where A, B, C are the dimensions of the physical quantity in mass, length and time respectively. Remember, in both the systems, dimensions will remain same. As the size of the fundamental units are different, so the numerical value will be different. What examples I told you. Suppose in one system values are given, other system you have to find. And size of the fundamental units may be given. Suppose in this system N1 is given to you, you want to find the value of N2. Just like a formula you can remember and solve this type of question. I can write this formula: N2 is equal to N1 into M1 by M2 to the power A, L1 by L2 to the power B, T1 by T2 to the power C, where M1, L1, T1 are the fundamental units in system 1, L2, L2, T2 are the fundamental units in system 2. And N2 and N1, they are the numerical values. If N1 is given, you can find N2. If N2 is given, you can find also N1. And dimensional formula or dimensions of the physical quantity will be given to you. Now, let us understand an example. For better understanding, let us solve a question. So now, suppose it is given to find out or to convert 1 joule into earth. It is given in the question, you have to convert 1 joule into earth. Joule is the SI unit of work or energy. The work or energy is given in SI system. We want to find in the CGS system. Org is the CGS unit of work or energy. It is given 1 joule equal to how many org. That we have to find using the dimensional analysis. Here two systems are given. First one is SI system, second one is CGS system. The value is given in the SI system and we want to find it in the CGS system. So in system 1 is system 1 is SI system. You can write in columns like that. This is SI system. And system 2 in this question, system 2 is your CGS system. The value is given in SI system and you have to find the value in CGS system. It is given 1 joule. Now what is the value of mass in SI system? The size of the fundamental unit mass in SI system is 1 kg. Similarly, length is 1 meter, time is 1 second and it is given 1 joule. So numerical value of the physical quantity in the SI system given 1. And we have to find the value of N2, that means the numerical value in the CGS system. In the CGS system, what is the size of mass? Mass is expressed in gram, length in centimeter, time in second, and that you have to find N2. Very simple procedure. So just you can put the values of N1, M1, M2, L1, L2, T1, T2 and you can solve it. Then what about the values of A, B, C? A, B, C are the dimensions of the physical quantity. Here the physical quantity is work. You know the dimensional formula of work or energy. What is the dimensional formula? So that is M1 L1 T minus 2. Sorry, M1 L2 T minus 2. This is the dimensional formula for work or energy. So here in this question, A equal to 1, B equal to 2, C equal to minus 2. Just put the values, you will get the value N2. So now after putting the values, so N2 will be equal to N1 is given 1, M1 by M2. M1 is 1 kg, 1 kg divided by M2 is 1 gram to the power 1. Then L2, here length is 1 meter divided by 1 centimeter and power is 2. Time in SI it is second, CGS also second. It is to the power minus 2. Now 1 kg by 1 gram. 1 kg how many gram? 1000 gram. So it is 1000 into 1 meter by 1 centimeter. 1 meter is 100 centimeter. So centimeter cancel out. So 100 square. 100 square means 10 to the power. This is 100 into 100. So finally, what will get? 10 to the power 7. So your answer is 1 joule is equal to 10 to the power 7 arc. So this is the procedure to convert a physical quantity from one system of unit into another using the dimensional analysis. What you will do? First, to write the values in the first system. It may be a regular system. It may be any other system. These are the well-known system. SI and CGS is simpler. The system may be different. It may be a new system. The value may be given. Haphazardly values may be given. Mass may be 20 gram. It will be given like that. Suppose the mass is 20 gram. Length is 30 centimeter. Time is 2 minutes. Like that values may be given. Just remember this formula. This is the one fact is that the numerical value or the magnitude of the physical quantity will remain same in different systems of units. So this one can be remembered as a formula and solve questions. Now let us solve another question based on this application. Suppose it is given, find out the value of 60 joule per minute on a system that has 100 gram, 100 centimeter and 1 minute as the base units. Base units means fundamental units. And the value of the physical quantity given is 60 joule per minute. Joule is the unit of work. Minute is the unit of time. The work by time, what is the physical quantity? The physical quantity is power. You know power equal to work by time. First, let us write the dimensional formula. The work done is mL2 t minus 2 divided by time is t. So what will be m1 L2 t minus 3. This is the dimensional formula for power. And power given 60 joule per minute. Let us convert minute into second so that you can get the value in SI system. So that is equal to the power given 60 joule per minute. So 60 joule divided by 1 minute is 60 seconds. So that will be 60 by 60, 1 joule per second, that is watt. The SI unit of power is watt. And in the SI system, the value is given 1. And we have to find the value in a new system. It is not a standard system. So now, two columns we can write, SI system and new system. SI system, M1 is 1 kg, L1 is 1 meter, T1 is 1 second, N1 is given 1 watt. In the new system, mass is given M2, that is 100 gram, L2 100 centimeter, T2 that is 1 minute, and N2 you have to find. Just put the values in this formula, you will get it. So N2 will be equal to, just write the formula, put value. N1 is 1, M1 by M2, 1 kg by 100 gram, 1 kg divided by 100 gram to the power, what is the power? the power is 1. Then what about length? L1 by L2. Here L is 1 meter, here 100 centimeter. The 1 meter and 100 centimeter to the power, what is the power? L2. And what about the time? T1 by T2. T1 is 1 second divided by 1 minute to the power minus 2. Now let us simplify this one to get the answer. So now 1 kg 100 gram. 1 kg you know 1000 gram. 1000 by 100, that is 10. So this is 10. This is 1 meter 100 centimeter. Both are same. So it is 1. And 1 second by 1 minute. 1 minute is 60 seconds. So 1 by 60 to the power minus 2. 1 by 60 to the power minus 2. That is equal to 10 into 1 into 60 to the power 2. So that is 3600. So it will be 36,000 new unit. We don't know what is the name of the unit. It is not a standard unit. So in the new system, the value of 60 joule per minute is 36,000. The numerical value is 36,000 if I take 100 gram, 100 centimeter and 1 minute as the fundamental unit. So this way you can solve many more questions. Now we have derived the dimensional formula of many variables, and also we have discussed the 3 applications of the dimensional analysis. Still then there are some limitations of the dimensional analysis. What are the limitations? First one, the dimensional analysis is silent about the proportionality constant. Suppose we have derived the time period of a simple pendulum t is equal to 2 pi root over L by G. Dimensional analysis cannot say anything about whether it is 2 pi or 4 pi or any other number. So it is one of the limitations of the dimensional analysis. And dimensional analysis fails when a physical quantity consists of number of terms. If number of terms are there, then we cannot derive the formula. Suppose S equal to ut plus half at square. That we cannot derive using the dimensional analysis because it is a combination of 2 terms. The another one important limitation is that when a physical quantity or the equation consisting of functions like trigonometric function, logarithm function, exponential function, we cannot apply dimensional analysis. And also another important limitation is that it is difficult to know the factors on which a physical quantity depends. The situation will be more complicated when a physical quantity consists of the terms like gravitational constant, Planck's constant, speed of light. It will be more complicated. So these are some of the limitations of dimensional analysis. And on the basis of dimensions, we can classify the physical quantities into 4 categories. First one, dimensional constant, dimensionless constant. There are 2 types of constants on the basis of dimensional formula. There are certain constants having dimensions. So they are called dimensional constants. For example, gravitational constant, Planck's constant, gas constant. So they are all dimensional constants. They are having dimensions. You might have found some of the dimensions or dimensions of some of these constants. Then there are some constants having no dimension. For example, any number, all the numbers are dimensionless. Pi, e, small e, these are the dimension. Pi, e, all the numbers, they are all dimensionless constants. Similarly, variables can be classified into two types: dimensionless variable, dimensional variable. Dimensionless variable means there are certain variables having no dimensions. For example, angle is dimensionless. Relative density or specific gravity, it is the ratio of density of the substance to the density of water. It is a variable. For different materials, the value is different. So it is a variable. So relative density or specific gravity, angle, dielectric constant of a medium, they are all variables but having no dimension. And dimensional variables, so there are many examples are there having variables having dimensions. So this way we have classified the quantities into four categories, that is dimensionless constant, dimensional constant, dimensionless variable and dimensional variables. So this is all about your dimensional analysis, and I will be sending some questions based on the third application. You solve and send to me.